Hello, we're going to get started in a couple minutes here. Give some people some time to go on and get their notes and stuff together. Alright, I'm going to get started here. We are going to be looking at solving quadratics by factoring today, and we are going to be doing more of this on Monday. So if you don't quite pick up on it today, Monday will give you another lesson on it to see if that helps at all. But all what we're doing here is just combining everything that we've been doing with quadratics up to this point. So you're going to be foiling things, you're going to be factoring things, so make sure you're still comfortable with that. And if you're struggling with it, ask for more practice, or redo some of the problems that we did earlier last week, things like that. You're also going to be combining like terms today, so make sure you're comfortable with that still, making sure you know that like exponents can be combined. And the other thing that we're actually going to throw in there today, which really isn't new, but we haven't used it in a while, is our zero product rule, or our zero product property, and that's what I have written up here. This is our zero product property. You probably are very familiar with it, due to the fact that it was like the easiest thing ever when you were learning your multiplication tables. But it states for any number a times 0 is going to equal 0. So anything times 0 equals 0 is what the zero product property is saying. And just to put that into some perspective, that means if you have something like this, right, which looks very familiar to you probably because we've been working with things that look like this for a while. If this statement is true, right, if you have x plus 3 times x plus 2 equals 0, if it equals 0, it has to equal 0, right, because that's our zero product property, things have to equal 0. That means that either x plus 3 has to equal 0, either this factor has to be 0, and then 0 times this would be 0, or your second factor has to be 0, so this would equal 0 times that equals 0. So if I wanted to solve this using my zero product property, I break it into these two statements, and then I solve both of these statements. So for this equation to be true, this has to be true or this has to be true. It's one or the other, and when it comes to quadratics, it's going to be both. So you got to be able to figure out both. And in this case, you're going to you can ignore the parentheses for each of them, and you can solve each of these pretty simply using your algebra, right? Minus 3, x equals negative 3. And over here, minus 2, x equals minus 2. And you should notice the opposite of whatever you're adding or subtracting there. But those are all your possible solutions to this problem. And that's the kind of stuff you're going to be asked to do today. You might have to factor to get to, in fact, you are going to have to factor to get to something that looks like this form. But we can do a couple examples of just using our zero product property. So if you're following along in your notes, your first example was x plus 5 and 2x minus 6 equals 0. And again, you can't do this unless they equal 0. So you're paying attention to making sure that they are equal to 0 here. If this is true, then to solve it, you're going to set each factor equal to 0. And you're going to solve for each of them. So here we're just going to subtract 5 from both sides, and x is going to equal -5. And here you're going to add 6 to both sides. And 2x is going to equal 6, and then you're going to divide by 2, and x is going to equal 3. And then if you want to check to make sure you're doing things right, you can plug them back in. Right? If I have -5 as my answer, then you'll see it'll be -5 plus 5, which gives you 0. And then whatever this is doesn't really matter because it's going to be multiplied by 0 to equal 0. Or this could be your 3. And this one won't matter, right? 2 times 3 is 6. 6 minus 6 is 0. This equals 0 now. So 0 times whatever this is going to be, it's still going to be 0. So these are your two solutions to this. And again, when it comes to quadratics, you have two solutions. So there's two of them. Give you another example, just so you have it in your notes. But a little more complicated for this one. We have 6x plus 9, or I'm sorry, that's a k, and 4k minus 11 equals 0. Again, first thing you're going to want to pay attention to is that do these equal 0? If they equal 0 and you're multiplying them, then your zero product rule is going to come in play. And that's going to state that 6k plus 9 equals 0, or 4k minus 11 equals 0. And then you just solve for both of these using your algebra. Minus 9 minus 9, 6k equals -9. Divide by 6, divide by 6k equals -9/6. And you can reduce that. I'm going to leave it as a fraction just because I like fractions. But I can divide each of these by 3 and get -3/2. So there's an equal sign there. And over here you're going to get plus 11 plus 11. 4k equals 11. Divide that by 4. Divide this by 4, and you get k equals 11/4. So you have your two answers right there. And if you plug them in, it would solve out just to get your 0. And it might actually be easier to plug in the -9/6 to that, because then the 6's will cancel out, and I'll just get -9 plus 9, which equals 0. And then the 11/4, the 4's will cancel out, and you'll get 11 minus 11, which equals 0. So again, that's just your zero product rule in play. That's all that is. So if you can remember your zero product property, and then just your simple algebra, you can solve these. Just keep in mind you got to do one for each factor. And then if you had a third factor, then there'd be 3 factors that you have to do this for. So not too difficult there, hopefully. Unfortunately, sometimes when you get your quadratics, they're not written in the form of like x, or I guess I'll use a minus b and a plus b or whatever. They're not written in this form. They're written in your standard form, which is your ax squared plus bx plus c. So they're going to be written like this, and in that case you need to factor in order to get it into that form. So you're just going to add that step to it. So let's look at something that's like that. In fact, this example here is going to add another twist to it as well, in the fact that it's not going to equal 0. So we have x squared minus 8x equals negative 48. Here you don't have something that's equal to 0, so you can't use your zero product rule. So you got to solve for that. What's more correct, a fraction or a decimal? Neither one is more correct. They're the same number. They're just written in different ways. A lot of people might not be comfortable with fractions. A lot of people might not like improper fractions being around. Your book doesn't like them. However, certain schools of math prefer the improper fraction over decimals just because it's easier to work with. If I were to bring back what it was, like 6x minus 11 equals 0, the improper fraction is easier to work with here because the improper fraction was what? Well, I'll just do this over again. Just to check your answer, right? Plus 11 on this side, plus 11 on that side. You get 6x equals 11. Divide by 6, divide by 11. You get k equals 11/6. This number here is reduced. It's just not a mixed number. If you want to leave it like this, that's fine, because when you go to check your work, it's easier, because you're going to do 6 times 11/6, where your denominator is just going to cancel, and you're going to get 11. And then minus 11 equals 0. So, I mean, it's personal preference, I guess. Depending on your teacher, you might have teachers that are like, hey, I don't want fractions, make them decimals. Hey, you can't have improper fractions, do that. I mean, I don't want you to leave things that are not reduced. So reduce them, but if you want to reduce it as an improper fraction, go right ahead. It makes, I mean, as long as you're comfortable with the improper fraction and you actually know what it means, it makes more sense in some situations. When you get in the trig class, you're always going to have 3 halves. Like 3 halves is going to be a standard number in trig. You're always going to have, hey, I want 3 halves. But that's for, just other things. So I'm going to leave it up to you. As long as it is reduced, it does not have to be a mixed number. I would get away from mixed numbers if you're doing it, just because typing mixed numbers might be a little difficult. But I'll leave it up to you. I can read a fraction. I'm okay with it. Over here, you can't use your zero product rule, and it's really not written in standard form because you don't have the C over here. So we're going to rewrite this to equal 0. So make one side equal 0. That's your first step here. So to do that, I'm just going to add 48 to both sides. I guess if you want the line. Right, that's going to get rid of the 48 over here and leave you with nothing. So hey, these cancel and leave you with 0 now. And you have x squared minus 8x plus 48. You can't combine anything here because there's no like terms. Once you get to this step, you're going to factor. So I'm going to come off to the side here and factor this thing. Squared minus 8x plus 48. Again, when it comes to factoring, just same thing we were doing last chapter, same thing you just had a test on, same thing that you're working on and fixing for the end of the day today. We're looking for numbers that multiply to 48 and add to negative 8. So the fact that this is positive and this is negative, so C is positive, B is negative, that means both my factors have to be negative. And factors of 48 that will add to 8, I am looking at, I hope this is factorable. What am I looking at? If you find it before me, just throw it in the chat. I'm not sure this is factorable. Some of them aren't factorable. That's another option you have. Some of them aren't factorable, and then you're going to have to use your quadratic equation. Pretty sure I just made this problem up, so it might not be factorable. And that actually might have been why I put it on there, because some of them you just can't do. Yeah, I'm not seeing one for this. So I'm going to say this is not factorable. You just can't solve it this way. But that might have been why I put it on there earlier this week. So this one here you can't do this way, which means you're going to want to use your quadratic formula for it. The quadratic formula will work for all of them. These numbers are going to be really ugly though. 4 and 12, negative 4 and 12. Yeah, but they both have to be positive because that's a positive 48. Unless I made a typo and I wanted this to be a positive 48, but when you bring it over, it becomes positive. And negative 12 times 4 equals negative 48. Well, then they'd both be 4 and 12 won't add up to 8. 4 plus 12, like if this is a negative 4 and that's a 12, that equals negative 16, not 8. So I think it might have been a typo if I wanted this to be positive instead. But if this is going to be negative, then I don't think this is factorable. I'm not finding it. So that one wasn't factorable, but let's just change it so it is, because you guys are coming up with that. So let's just start over. That's good practice, because again, some of these just aren't factorable and you won't be able to do it. So 8 squared minus 8x equals, what if I said that was positive 48? Then your 4 and 12 will work. So in this case, you want to get it to equal 0. So again, make it equal 0. You're going to subtract 48 from this side, and then you're going to get... Oh, what, did I do that wrong? You're going to get x squared minus 8x minus 48. So maybe I did screw up. Maybe I wasn't seeing something before. Let me rethink that. You need 48. You got 4 and 12. They need to add to 8. But these have to be the same sign if this is positive. So there's no way that's going to work. If this is negative, then these have to be different signs. Yeah, that's how it works. Yeah, okay. Then this is negative, so these have to be different signs. So that has to be negative 12, and that has to be a positive 12. So then when you factor that out, this is going to equal 0. Here we're going to factor, which is that work up there. And then you're going to factor it, and you're going to get x plus 4 and x minus 12 equals 0. And I'm just going to double check that because I'm questioning myself now. It becomes x squared, x times negative 12 is negative 12x, that's 4x, and that is negative 48, and then here's your negative 8, so yeah. So that works. That equals 0 now, so now you can use your zero product rule to answer this and actually solve for x here, you can split this up into x plus 4 equals 0 and x minus 12 equals 0. And that you probably can do in your head. I don't know why I wrote it like that. Let me write it over here. X plus 12 equals 0. So one of these has to be true for this statement to be true, and therefore both of them are going to be your answer. And you just solve minus 12, x equals negative 12, and x equals negative 4. And you'll notice just the opposite of this one. You don't have an a value in front of any of this. So your answers here are negative 4 and negative 12. If you had 48 positive, you can do negative 4 and negative u factors. Yeah, but negative 4 plus negative 4 doesn't equal negative 8. Right, if this was positive, then they'd both be negative, then that I would add up to negative 16. That's why I think it's probably a typo. Or I put it on there specifically saying that, hey, some of these you can't do this way. I don't remember what I was thinking when I typed it up, but there is a possibility, just like, hey, you wouldn't want to graph this probably and count out to like negative 48. That just probably isn't the way you want to solve this. You won't be using your square roots to solve this because you have that b value and you don't know how to combine this x with that x to get one variable. So you wouldn't use it that way. This is just another way to solve them. However, there are certain cases where this just isn't going to work. And keeping in mind, there's also cases where there's no real solutions to these, where your graph doesn't cross your x-axis, so you can't solve it that way either, which is where your quadratic formula is going to come in play. Your quadratic formula is like the groundbreaking invention that solves all of these no matter what. It will even give you the imaginary solutions to it. It just, I screwed that up. It's going to annoy me. It's just going to give you, you know, you don't know how to read imaginary numbers right now, and I'm not going to get into it. So let's go through another example. Hopefully this one works a little better. But this one has a value out front. So here we have an a value to this. And that's going to throw off a little bit, but not much. If you pay attention, it actually isn't going to be any more difficult. In fact, it's probably going to actually save you some steps in factoring if you actually pay close attention. But I'll leave that up to you to pay close attention to. So first step you want to do is you want to make this equal 0. So make it equal 0. Right now it equals 88, so I'm going to subtract 88 from this side and subtract 88 from this side. So I get 2x squared minus 5x plus 88 equals 0. I don't know why I picked high numbers. But there's that. Next you're going to factor. So to get the next thing, we're going to factor this. We're looking for factors. Here you'll note that we have a value, so we need to multiply, slide and divide. You get x squared minus 5x plus 2 times 88. It's 176. And now you got to sit there and figure out 176 factors. So if you find it before me, let me know. This is positive, so signs have to be the same. This is negative, so signs have to be negative. And hopefully this one works, because I think I did just make these up. But let's see what happens. Yeah, I'm not finding one for this either. Well, first off, this is negative. That's a problem. I'm subtracting 88. So this has to be negative, which means one of these is positive and one of them is negative. So there's one mistake I made. Getting 16 and 11. Okay, Dan's getting 16 and 11 too. And again, one has to be negative for this to work out, and because this is a negative 5, it's the larger one. So negative 16 and 11. With that, get x minus 16 and x plus 11. Again, this is all equals 0, but then you got to bring that 2 back into play. So you got to divide this by 2, divide this by 2. Don't forget about your divide part. In that case, you're going to get negative 16 divided by 2 is going to give you x plus or minus 8. And over here, you're going to can't do that. In all honesty, you're going to move this out front, but you're actually not if you think about it. Plus 11. And then you're going to solve using your zero product rule. So we got 8 minus 11 equals 0, and you got 2x plus 11 equals 0, plus 8, x equals plus 8, which you will note is the opposite of this. And over here, you are getting minus 11, and you get 2x equals negative 11. Divide by 2, divide by 2, you get x equals negative 11 halves, which you will note is the opposite of this. So they're really just the opposite of those numbers. And again, if you want to put it as a mixed number, that's fine. Just be careful on typing it. But yeah, you should note that if you do the slide and divide method, once you get to this step here, it's the opposite of whatever these numbers are. And that makes sense because when you do the division thing, it's the same thing, really. But yeah, just a little trick if you don't want to finish off all your work, I guess. You did enough to get your answer just from that. We're going to do one more, and this one's going to be the long example. So this is going to go through everything. And if you didn't take down any examples, this is the one that you should be taking down, because this one here does not equal 0 and is not in standard form. So we have issues. And again, I don't know why I was thinking big numbers today, but I was. Well, actually, I was doing this Sunday, so whenever I was thinking this, I was thinking big numbers. Here, you need this to equal 0. But when you do so, you're not going to be able to combine very well. So the first thing you want to do is actually write in standard form. So you're going to FOIL this. That's going to be your first step. So we're going to FOIL that. So this becomes x squared. This becomes positive 6x. This becomes positive 8x. And this becomes positive 48. And then you're going to combine like terms. and you're going to get x squared plus 14x plus 48. And again, it doesn't equal 0 here, it equals to 288. So I guess I shouldn't put that there as well. Equals to 288. Once you get here, you want one side to equal 0. So make it equal to 0 here. And you're going to do that by subtracting 288 from this side and subtracting 288 from that side. And you get squared plus 14x minus, what is that? 240. 8 minus 8 is 0, 8 minus 4 is 4. Yeah, negative 240. And that's going to equal 0. And then you're going to factor this. And that's going to be a pain too, but oh well. Going to factor this, and we're going to get that 2 out of the way first. So we're going to get x squared plus 14x, and that is a negative 240 times 2 is 480. 0. So I want factors of 480 here. That'll add up to 14. This is negative. So one has to be positive, one has to be negative, and the higher one has to be positive. So go ahead and figure that one out. Again, if you get it before me, throw it in chat. Oh wait, this is why I'm screwing up. I'm doing bad today, guys. There's no 2 here. Where did that 2 come from? That makes more sense. Then you don't slide and divide that out. And this is not 480, this is just negative 240. And then I think that's what? 24 and 10. Yeah, sorry about that. I'm messing up a lot today. That's okay. We'll do more examples today. We're going to be doing more on Monday too. In that case, you get, let's see, one of these has to be positive. That has to be positive. In that case, you're going to get x plus 24 and x minus 10 equals 0. And then again, separate them out, but it's going to be the opposite of these. So your answers are going to be x equals negative 24 and x equals 10, because they're going to be the opposite of them. But we'll solve it out just to double check. Subtract 24 from that side, subtract 24. Hey, there's your negative 24. And over here, x minus 10 equals 0. Add 10 to this side plus 10 to this side, x equals 10. And there's your 10. So that's going through all of it. I know it's quite a lot of steps to do that. I don't think your work today is necessarily going to work out all of it. And 16 and 30 work for the other one. Yeah, I guess it did. Pretty good, Gabby. Unfortunately, I didn't have that 2 out in front. That's why I wasn't finding it. Yeah. Your homework assignment is page, was it 538, 7 through 21. I'll start it with you just to give you some more examples. It's going to start off, it's easier than the ones we did today because you're not doing every step. But if you want to look at number 7 with me, we can. And I can stay on until you guys feel comfortable doing things for today. But again, we're going to look at this again on Monday. So I'll go through some more examples on Monday and check your work. 538. So what it is? Yeah, 538. I'm not sure what you're saying there, Dan. 7 says b squared plus 3b minus 4 equals 0. And again, this isn't anything. This is, hey, just factor it and solve for x. Or, well, solve for b in this case. Here, we already have it equal to 0, so you're just going to factor. And this shouldn't be too hard to factor compared to the other ones. These numbers are smaller. So you got a negative 4. You want a positive 3. So these have to be different. So it has to be 4 and negative 1. So 4 plus negative 1. And again, you're just going to get, with no a value, it's just going to be the opposite of these two numbers. Those are going to be your answers. But we'll go through it the whole way. So you're going to get b plus 4, and you're going to get b minus 1. And they equal 0. Set them both to 0 and solve. Minus 4, b equals minus 4. Over here, plus 1, b equals 1. So again, your answers here are b equals 4 and, or I'm sorry, negative 4 and positive 1, which you'll note is the opposite of your factors here. And that's going to be true as long as you don't have an a value here. It just works out that way. So it is kind of less work than you were doing before if you wanted to stop there, but I mean, you should realize you're doing the solving using the zero product property to do all that. So that wasn't too bad. Number 8 I'll walk you through as well, just to give you some more examples, more practice with it. M squared minus 5m minus 14 equals 0. And again, it's already set to 0, so all you got to do is factor it, which you've been doing all week, so factor this. So we need negative 14, which means signs have to be different. Larger one has to be 5. So what is that, 2 and 7? And larger one has to be negative. So again, you're just going to have, your answers are going to be the opposite of these two numbers, but just so we go through the whole process. And they equal 0, so set them each to 0. And n plus 2 equals 0. Minus 2, m equals minus 2, and plus 7, m equals 7. So your answers are n equals 7 and minus 2. Not too difficult. Let's see. Let's get a more difficult one. Let's get one with an a value or something here. I guess 15 might be a little weird to you, but it's done the same way. We can look at 15. That's n squared equals 6n. Here you got to get it equal to 0 first. To get it equal to 0, I'm going to subtract a 6n from this side. You could have subtracted an n squared from that side for all I care. It doesn't really make a difference. But if I subtract 6n, then I keep my a value as 1 as opposed to negative 1. So it's going to make more sense to me to do it that way. So that becomes a squared, or n squared minus 6n equals 0. And then again, you just factor that. Keeping in mind here, your c value is 0 in this case. So you need factors of 0 that are going to add up to negative 6. So that's negative 6 and 0, which isn't too difficult to figure out, hopefully, for you. So you know that we have n, what was that, minus 6 and n plus 0 equals 0. And in this case, n minus 6 equals 0, n plus 0 equals 0. In this case, your n is going to equal 0. So 0 is your answer over there. And over here, you can have positive 6. So in this case, n equals 6 and 0. Just so you know. And again, that makes sense. If you plug in 0 for this, for n, you're going to get 0. Right? 0 squared minus 0 is 0. You plug in 6. 6 squared minus negative, or 6 times 6 is going to give you 0. So you can check them. I highly encourage you start checking them because that's how you really understand what's going on. But let's get one with a value again so you can look at that. Yes, 16 has an a value. So this one has that a value there. So first step, you want to get it equal to 0. So that's going to be 2c squared minus 7c. And again, you're adding 5 to both sides. So plus 5 equals 0. Then you're going to factor, so slide and divide that out. You get 2c minus 7c plus 10 equals 0. Factor the 10. You get, see, they have to be 2 and 5 again. And the 5 has to be negative. So you get c plus 2 and c minus 5. And don't forget about that 2 coming in. So don't forget to divide each by 2, divide by 2. And you know your answers are going to be the opposite of these fractions, really. But we'll do it the long way. C plus 1 and C, oh, that one doesn't reduce, so your 2 comes out front, minus 5 equals 0. So C plus 1 has to equal 0, and 2C minus 5 has to equal 0. In this case, you get minus 1, C equals negative 1, which is the opposite of this, which is also the opposite of this. So be aware of that. This is a minus sign. And here you add 5 plus 5, you get 2c equals 5, divide by 2, divide by 2, you get c equals 5 halves. And again, if you want to leave it as 5 halves, go right ahead. If you want to put it as 2.5, go right for it. So c here is going to equal negative 1 and 5 halves, which is the opposite of this, right? You just change your sign. Again, if you wanted 5 halves to be, what is that, 2.5, you can do that as well. It doesn't matter. Again, it might be weird typing the mixed number, so you might want to stay away from that. With that, I'm going to let you try them. Take your time on them. Again, we're going to do this Monday as well, so this does not actually have to be in by today if you don't get to it or if you still have questions or something. Just on Monday, I'm going to give you more to do. It's the same kind of thing though on Monday, so it's just going to be more practice. So again, if you have questions on things, feel free to email me. Just try them today. That's all I'm asking. Try some. If you don't finish it or if you don't get them all, that's fine. You'll have more time later. So don't stress yourself out. Again, it's hard for me to judge how much work you're getting from other classes as well. But math, I think, is a little important because you're eligible to take your keystone for it after this class, and you kind of need to know this stuff. So if you have questions, send me an email, and I will talk with you on Monday. Have a good weekend. Go outside and play some. Just stay away from other people.